In this section, we also talked about how to find the midpoint of 2 points. So if I were given a coordinate plane such as this, let's just go ahead and say this is the origin. And so what you can typically remember is that if this is the y, and this is the x. So let's take 2 points here just for example. So let's go here. This is point A. And let's go over here and call this point B. So we could find the coordinates of these just by counting. So it goes over 2 and up 1. So A is a point 2, 1. B goes over 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 to the right and up 1, 2, 3, 4. So 9, 4. And that's kind of a weird place to put it. It would be more common to put 9, 4 to the right of the B for that more typical notation. Great, so if I were to ask what is the midpoint of AB, so AB with a line across the top, that means the midpoint of the line segment AB, which isn't drawn yet. So it might be a good idea to go ahead and draw that line segment. So let's just draw it in there. So the midpoint between 2 points, or the midpoint of the line segment AB. Let's just go ahead and get rid of these extra lines here for a moment, and then we'll bring them back in a little. So in this case, what you might do is one of 2 or 3 different things. So I could visualize it here if I wanted, right? I could, if I were to do something with a compass, right? I could maybe draw concentric, oops, excuse me, I need a pen to put back on. I could draw concentric circles to try to pinpoint, you know, where the midpoint would be. That's an option. That would be the way Euclid would do it in his geometry. But in this case, since we're given coordinates, we can go ahead and use coordinate geometry, which was introduced by Descartes, in order to find this midpoint, which I'm just going to eyeball here with a little dot. So the midpoint. Well, the formula that we're given for the midpoint, we'll call it here M, is that the midpoint is found by taking the average, in the sense of the mean, of the x-coordinates, and that will be the x-coordinate of the midpoint. And then take the average of the y-coordinates, and that would be the coordinate of the midpoint. And so, in other words, what you might think is, if I want to find the point exactly in the middle of A and B, find the point that's in the middle of the x's, and find the coordinate in the middle of the y's as well. So let's do that for this example. So we've been given A and B, and the x-coordinates on A and B are 2 and 9. So what you might do, you're definitely not to do this, you could do it in 2 different parts. I prefer to do this, so I might do something like find the x point, or the x-coordinate. Maybe even just use the word, the x-coordinate. That's, if you can write more neatly than I can with this computer, good job. All right, so the x-coordinates, well, we have 2 and we have 9, and we cut it in half. That gives us 11 halves, and for our purposes, you can either call that 5.5 or 5.5, whatever you prefer. And that will be the first coordinate of M. And then I would go ahead and find the y-coordinate. Let me scroll this down a little bit. So y coordinate. It's 1 and 4 divided in half. So that's 5 halves, or I'm just going to write it as a decimal, 2.5. So there's the midpoint. So the midpoint of our coordinates A and B, this midpoint of the line segment AB, is given by M with coordinates 5.5 and 2.5. A couple things here that are very common. It's very common to accidentally subtract because you're used to subtracting things when you do distance formula, for instance. We need to add them. What we're doing, we're finding the average. We're finding the mean. And so we add those two together. Another good thing is use just this common sense idea that the midpoint had better be between the other two, right in the middle. So what's the middle number between 2 and 9? It's 5.5. What's the middle number between 1 and 4? It's 2.5. And so if you were to subtract, for instance, I would be getting numbers that were very different from these. As an extreme example, you might say something like, well, if my points, were, say, C is 5, 7, and D is, let's say, 6, 8, clearly the midpoint, what's the middle number between 5 and 6? It's 5.5. And if I were to do this formula with the midpoint being 5 plus 6, I would get 5.5 for the x-coordinates. And likewise, 7 plus 8 cut in 2, I get 7.5. If I make the mistake here about subtracting instead of adding, I'd be getting numbers that were negative or very small, less than 1, and that is not in between these two. So an easy way of checking that is make sure that each x and y fall in between, and also look at your picture. So let's get these lines back on there. With just eyeballing it, I think I did an okay job eyeballing that. I end up with this point that is 1, 2.5 up, and then over to the right, 1, 2, 3, 4, 5.5. So use the picture to guess it. Honestly, for most of these sorts of problems, if they're finding the midpoint between whole numbers, it's either going to be directly on one of these lines or with a half. And so eyeballing it is very straightforward with these. Where it becomes a little bit stranger, and we are allowed to do this, is if my original points weren't nice. So if my original points, were weirder. So I could, for instance, have the point, say, E is 5.3 and say 9.11. And then F could be something like square root of 2 and pi, whatever you want. So these are still numbers. And I could still find the midpoint of these, but it wouldn't be quite as nice. And so for ones like this, definitely use the formula. Ones where you have integers for your coordinates, I say use the formula so you learn the method, but it's normally sufficient to get an idea of what the answer is to graph it and observe. All right, I hope this helps.